Hello everyone. Today I would like to represent our capstone project stairway design for the Eldred Atrium, which is prepared by Mugdha, Choksi, Gandhi, Dhruti and Lee Jason under the guidance of Ben Allard, Academic Advisor, Industrial Advisor Branislav Papik, Capstone Advisor Dan Shipra and our technical guide Penelope Shrive.
The agenda for the today's presentation is what is stairways, why a particular type of the design has been chosen, its structural analysis, 2D drawings and the cost analysis. The staircase has been designed in the atrium of Eldred Center because electronic stairs and elevators are almost always full or under maintenance or sometimes not working. Spotting the stair as soon as you entering through the main entrance of the Eldred Center, it provides sense of comfort and ease of commute to the other floors as and when required without waiting for elevators. As we all know, tread is one of the most visible part of the staircase structure, horizontally placed above the risers where we physically put our feet on. Risers are the elevations provided between consecutive stairs. To support the treads in position, stringer beams are provided laterally beneath every flight, whereas support beams are provided below every landing to support its connection with every level. The only difference that put landings and flights apart is its width and its connectivity post every flight to other floor. As it is clearly evident in the picture that the elevation difference between the levels is not similar. If any design of stairway except for a continuous pattern was opted, would lead to a different riser height for levels 2 to 3 and 3 to 4, leading to a discontinuity in the rhythm of travel, causing inconvenience to one's commute, which many a times lead to people tripping or many a times falling and injuring oneself. Also, the compact design makes the structure less overcrowded since we already have the exposed trusses in the structure.
For designing any structure, one of the most vital consideration is the loads acting on the structure. Here, there are two loads which are acting on our structure. The first one shall be live load and the second one shall be the self weight of the structure. To exemplify both of them, live load is the load that the end users put on the structure while its usage, whereas dead load is the sitting load which doesn't have any movement but is constant and consistently put over the structure, such as the dead load of the tread plates on the tread itself, whereas the dead load on the stringer beam shall be a little different than the dead load on the tread plates, that is the dead load of the tread plates itself and also the dead load of stringer beams which the stringer beam will resist. For designing the staircase, first the number of required risers were calculated. The risers can be calculated by the formula total height of the floors by the height of risers. Here the height of riser is taken as 210 mm as per the minimum requirement of the National Building Code. Using this riser height, the number of risers used for level 1 was 29. The number of risers used for level 2 and 3 were same, that is 23 each. The number of risers for level 2 and level 3 were same since the height for the floors 2 and 3 are same. Going ahead with the landings which connects each flight to the floors, the landing plates were designed to be of the dimensions 2 meter long, 2.5 meter wide and 28 mm thick. The following dimensions were given since the plate was failing in deflection if any dimension less than this was taken. Therefore, the end result of the landing plate was as follows. Since it satisfied the deflection requirement, the shear requirement and movement requirement. Going forward with the design of the tread plates, a HSS 305 into 125 into 6.4 was opted for since it satisfies the minimum width requirement of code, which is a tread plate shall be no less than 220 mm wide. To go for the factor of safety and provide a wider tread, a tread plate of 305 mm width was opted for. Therefore, the number of tread plates can be calculated by the formula number of risers minus 1. Therefore, the number of tread plates for level 1 to 2 was 28, 2 to 3 was 22, and the same for level 3 to 4 since the height between both the floors are same. And every tread plate, every HSS tread is covered with a tread plate and end welded. So when both of them are end welded, it will act as one whole structure. After designing the treads and the landings, the next step in designing was designing the beams and required columns for the structure. We have two beams in our structure. One shall be the support beam and the other one shall be a stringer beam. A support beam is provided beneath every landing to support the landing in its position. Therefore, the beam which was light and which proved to resist the required shear, deflection and movement was a W100 into 19 with a length of 2 meters having a yield strength of 345 megapascals and was of class 1. Going forward with another type of beam, that is a stringer beam, which is provided at both the lateral ends of each flight. The stringer beam that was designed for level 1 to 2 was a W310 into 31 with a length of 10.20 meters, a yield strength of 345 megapascals and a class 1. This beam was the lightest which could resist the required shear, movement and deflection for the floor. Going ahead with the another two floors, the beam was same for them since their beam height is same and the load acting on them is approximately of the same amount. Therefore, the beam that came out to be the lightest and which could resist the required forces was a W310 into 21 with a length of 8 meters, a yield strength of 345 MPa and a class 1. Going ahead with the column design, only a single column is provided at the intersection where the landing is connected to level 1. This column is only provided to provide extra structural resistance to the structure. A rectangular HSS was not opted in this structure since the installation of a square HSS is way simpler than installing a rectangular HSS. The square HSS, which proved to be the lightest section and resisting the required movement, shear and deflection for the structure, was a square HSS 127 into 127 into 4.8 with a height of 6 meters, a yield strength of 350 megapascals, and which was better than class 1. While designing a structure, some of the National Building Code requirements are a necessity to be followed, which is one of the design constraints while analyzing any structure. Not to forget, the weight of an assembly plays a very vital role. Also, while transportation, if the structural length is too long, then it could be an issue while transportation and we will have to pay extra cost, or there is a fear of damage while transportation. Additionally, the weight of the assembly also plays a crucial role while earthquakes. If a structure were to fail while an earthquake, or if the structure were to get damaged while installation and fall, the structural weight shouldn't be as high that if it were to fall or fail in any given circumstances, that should damage the things underneath it to a very high extent.
Okay, so this is the stairs for the first floor going to the second floor. So pretty much the first floor stairs will have 28 treads at 305 millimeters, and this 8.54 meters long and 2 meters wide for the treads. The landing is 2 meters wide and 2.5 meters long. The landing has a 28 millimeter width. The drawings have a side and top view. The stairs will be 6 meters tall and is supported by a column under the landing, as you can see. The treads will have wood planks on top of them, and they can be replaced when needed. The stairs will have a post on the treads which is connected with the glass panels, and the handrail is 40 millimeter wide, and the angle of inclination is 35. So for section 2 to 3, both lengths are 2.5 meters, and there are 22 treads at 305. Like the first floor, you'll have the same size for the handrails, the same for the glass panes and posts. So pretty much unlike the first floor, this isn't connected by a column. So pretty much for third to fourth floor is pretty much the same as the second, exact same. So pretty much it has a elevation of 4,700, while the first floor will have an elevation of 6,000. Okay, so here's the table for dimensions of the treads, beams, columns, and landings. So pretty much you can see that 2, 3, 3, and 4, they're pretty much exactly identical. This is due to them having the same elevation difference, which is 4,700. So pretty much the reason why I use AutoCAD instead of Revit or SolidWorks is that this semester like we just started learning how to use Revit and I wasn't familiar with it, like I wasn't confident in it. So that's like the reason why I use AutoCAD instead of Revit.
Cost analysis. Cost analysis play a crucial role in any construction project. It can make us win or lose a bid. There are several softwares which are used for estimation such as ProS, Candy, Costex, and many others. Here we have opted for Excel as a quantity sheet to provide in-depth explanation of different considerations adopted for the estimation. Over here, we have focused on cost breakdown of a components like steel, wood ply, and glass panel as they are the major part of the structure. The structural anchorage is considered to connect existing concrete structure with the new structure, steel one, which is widely used in Canada to provide an anchorage without setting that particular area. And for that same purpose, we have provided one of the best Hilti anchorage. Moving forward with the pricing of the components, for bulk steel pricing, it's taken from the Stats Canada, which is 6,000 metric ton. For the wooden ply, we choose G1S, which is good on one side, over G2S, which is good on two side ply, as there is a hike in price of $11 to $13 per ply, and to decrease the unnecessary cost in the structure. We have chosen G1S half-inch ply 4x8 sheet, which costs $66.22 per sheet from Lowe's. A simplistic version of the estimation has been explained with the required data. On the basis of dimensional detail in load calculation, we have used the dimensions and the class of structural steel members based on the structural analysis. Each steel section has been based on the rates per Stats Canada, which is 6,000 metric ton. Similarly, other costs have been taken from the market rates such as Home Depot, Lowe's, and much more. The final cost of the following the project scope comes out to be $93,000. To conclude the project, I will hand it over to Dhruti.
The team has reached to a conclusion that the current design can be implemented incorporating some of the alterations such as re-verifying the design requirements as per the latest code release, the testing of the structural application, and also adding all the excluded cost parameters to the estimates. As of now, the design is based on the NBC, that is National Building Code 2019 version, CSA, which is abbreviated as a Construction of Steel Design Handbook 11th edition, and estimate has been manually done using the quantity sheets. To verify the appearance of the structure, a 3D model should be made to have the actual visualization of the structural implementation. The project wouldn't have been completed without the endless support of our advisors Branislav, Ben, and Dan. A special thanks to Penelope for letting us use the structural steel materials provided by her.
Here are some of the references that have been used for the presentation. A full list of the references is available upon request. I would like to thank the audience for taking the time to come and see our presentation on the design of Eldred Arterium Stairway. Now we open the ground for any questions, and we would answer them to the best of our knowledge and try to solve every doubt as clearly as we can.